Yeah, hi. I'm Martin, and I work on source control stuff at Google. And yeah, I'm going to show you a demo of Jiu-Jitsu. Um, and it's a Git compatible VCS, so we'll be using it uh, with Git. And this is what you see on the screen here is a clone of the Git repo itself from a few weeks ago. Um, and so it's Git compatible. You can use it with existing Git repos, and no one will know that you're using something else than regular Git. Um, and one unusual thing about Jitsi is that the working copy is modeled as a commit. So the at the top of the log there, the commit that has this @ symbol, that's the working copy. And it's currently empty, meaning there are no changes compared to its parent, and it has no description. You can see the commit hash, which is the regular Git commit hash, and the highlighted part is what you need to specify to make it unique to address it. So you can use JD show D, for example, to look at that commit. And on the left here is what we call change ID, which is kind of like a Garrett change ID. It stays with the commit as you rewrite the commit. Yeah, and so the working copy commit, uh, it whenever you make changes in the working copy, the next JD command will automatically snapshot those changes, and it will go into this commit. So let's do that. Make some change to this README, and that will give us a new commit hash. So you will see this change, but the change ID will stay the same. There, it's no longer empty. It doesn't say empty anymore, and there's still no description. And because it's an actual commit, we can set the description at any time. So okay, first let's look at the changes in that. So that's what you would expect. This actually does the snapshotting if necessary, and then just diffs the two commits, the working copy with against its parent. So as I said, like we can set the description at any time. So now it has a description too, and you see this still is called T, and the commit ID changes. So let's say we're done with this change now. We want to start a new one. We run JD new, which creates a new commit on top. And now that's empty, and we can start adding changes to that. So let's give it the description and make some changes to the file. And looks like that. And as I said, it's Git compatible. So this setup I have here is called what we call a co-located repo. You can run Git commands like mixed with JD commands. So that shows the same diff, and also reminds us that JD doesn't support Git attributes yet. So we get some warnings here. And we can go back and edit a previous commit too. So the T commit, the parent, if we can edit that in the working copy directly. So like that. Now we're on this commit. So this is our working copy. So if we make further changes, that will go into this commit or this change, and the descendant S will be renamed on top. So we'll make some further change. Verify. It looks like this now. Yes, so as you may have noticed, there's like no no staging area. So maybe you're thinking like that this takes away a lot of functionality that you used to from Git, but like I would say that JD probably makes it at least as easy to like create commits incrementally and move changes around. We have a lot of commands for moving commits and moving parts of commits and splitting commits and so on. And it's not just the working copy commit like you would typically do with Git checkout. It's called -b and so on. So for example, we have squash takes an arbitrary commit. In this case, I'm saying squash commit S into its parent and give it a description like that. Yeah, that's about the working copy. Another feature is the operation log. We keep a log of all the operations in the repo. And for example, in this repo, that looks like this, the most recent operations here. So as you see, what I just did, the squash is recorded here. Before that, was some snapshotting of the working copy and so on. And this is very useful for like debugging, troubleshooting, and like especially if you're looking into someone else's repo and wondering why it looks the way it currently does. We can we can run any command actually at almost any command at the previous operation, and it just loads the repo at this operation and runs the command. So if we run log at this operation, which was here just before squash, we're going to see the way the repo looked at like just a few minutes ago. We can undo just does the inverse operation, most recent operation by default. So we can undo that, and now our repo is back to where we had the two commits on top of each other. We can look at past operations. I think this was a snapshotting operation where we added this BVCS parenthesis. And we can like go back to arbitrarily far back in the history of the repository. So so this is this operation here is where I had just cloned the repo. So if we go there, it's the start. It's the empty just after cloning it, the git repo. And we have copied a lot of features from Mercurial. So RevSets is one of them. RevSets is short for revision sets, and it's a language for selecting revisions or commits. So I'll show some examples. For example, if we look at master, minus means 3 generations back from master. That was apparently these 3 commits. We can find all the root commit. JJ has also a copy from Mercurial. A virtual root commit, that's the common ancestor of all commits. So if this expression here selects the root commit, plus means all immediate children of the root commit, and we also add in the root commit itself. It shows these like Linus's first commit and the initial gitk commit and so on. Or we can look at all the tag commits that have never been merged into master, which is these. So these were presumably cherry-picked into master instead. We can find all tag commits that did not have gitster as the committer, and limit to 5 just to fit on screen. Finds these commits. Yeah. Then next feature is conflicts. JJ is able to store conflicts in commits, and it's not conflict markers, but like a representation of conflicts that happen. So to show you how that works, we'll create some files, create some commits with some modifications in some files. So in the first commit, we add a file with contents food, and we modify it to bar on one branch in Y here. On the other branch, like but by the way, there are no actual branch names, as you may have seen. There's the master, but JJ also keeps track of anonymous heads is what we call them from copy from material. So all your commits are kept track of. They're not going to be garbage collected or anything. Yeah, so on one branch here, we modify the file to have contents bar, and on the other side we set it to BAS, which obviously is going to create a conflict if we merge these together. And then we add a second file with contents foo and modify it to have contents bar. So now if we rebase these three commits, R, W, V, and U onto Y, we're going to get conflicts. And yeah, as you see, we got conflicts in R, and they remain in the two commits on top because we have not resolved them. But the rebase succeeded, and we can continue, and we can resolve them whenever we want to. We can check out another commit and work on that before we resolve it, for example. But let's say we want to, yeah, this is how, in the working copy, we obviously the file system doesn't understand conflicts, so we have to store the conflict in some way in the working copy, and we materialize it as these funny looking conflict markers. So let's say we resolve this conflict with this content bars. And so when we do that, you should see that there's no longer conflict here. Yep. But this was a conflict in file 1, so suppose we should have done it in this commit in R, right? So we can just squash that conflict resolution into R. So this takes the changes in the working copy commit, which is a conflict resolution, and we squash that into R. Done. So now the conflict is gone from R and all the descendants to as you would expect, hopefully. And like this, like better understanding of conflicts lets us do a lot of move commits around and in much more freely than you would get. So for example, like if we want to put R before Y, that will cause conflicts because it modifies the same file, and you get a conflict. But like interestingly, there is no longer a conflict in the child because the sum of the changes is still the same in Y because we still had R and Y at that point. And we can rebase R after Y again, and the conflicts will go away. So I mean, it's clearly not just conflict markers that are stored. We can also parallelize all these commits, so flatten them out to be siblings. So master to the parent of the working copy means V, Y, R, and WV. So we're going to make them parallel, and U will be still a child of all of them. So as you might expect, there is no conflict in the commits that added new files, but there are conflicts in the commits that modified those files because they're now on top of master directly. And in U, which is on top of all of them, that's the merge of all the other changes we had. So it still has all the changes. So there's the sum of the changes is still no conflict. So U is a simple change that just modifies file 2 from foo to bar as before. And that's what the diff shows as well. And we can squash these commits together. This expression here that says the parents of the working copy, so that's all 4 commits. We squash them into the working copy, which is implied, and there's no -- into at, but that's implicit. So we squash these 4 commits into the working copy itself, and so the working copy will still have the same sum of changes, which is no conflict. So now it has all the changes from those 5 commits in one. And the content is what you would expect. So last time I was here at Git Merge 2 years ago, I talked about our plans for integrating Jiu-Jitsu at Google, and now most of that is done. So I'm going to show you a bit what it looks like. So we'll go to a repo, cloud repo that I've prepared, and run JJ, and it looks about the same as it did in the Git repo. But I can hear all the commits and operations too, and trees and all that stuff is stored in the cloud, and just fetched on demand from the cloud, and with some local caching and stuff. And so this works by, so JJ has like pluggable storage backends, so we're able to just replace the backend for storing commits and so on at Google, so we can store them in a database instead of storing them in Git repos. So we can make some changes here too. There are some changes, and this backing up to cloud thing is, we have a local process that does the caching I mentioned. So when you create we create the commit here, when just running JD, so it snapshots the working copy. That creates a commit and sends it to this daemon, and it flushes it to the server in the background, and that's what this is about. And so this number here, so CL 500 million something, that's kind of like a sequence number for commits at Google. So this is kind of like being at commit number 500 million in our repository. It's not completely dense, there's some gaps, so it's not quite that many, but close. So let's now sync to CL 600 million. Takes, I don't know, a second or two, which is pretty good for syncing past 100 million commits. And this works by, like, it asks the server for the most recent commits, downloads that commit and the trees, and runs all the same client code as you would as it does in like a Git repo. And so now we're on top of CL 600 million something. So, and in this mono repo we have here at Google, it's you saw we have these hundreds of millions of commits, and we have many millions of files, but we can still list the set of files in a specific fitting a specific pattern in reasonable time. I don't know, this took like a second or two, and I flushed the caches, by the way, before this demo. So this is the real performance. And we can look at a diff of a slice of a repo from CL 550 million to 600 million roughly, touching these paths. And you get the result in reasonable time too. And the way we have set this up, everyone's commits are available to everyone. So from every repo, and for example, here this commit I'm looking at here, I created from some other repo or workspace a while ago, and like you can access anyone's commits from anywhere. You can cherry pick them or just inspect them or check them out and so on. Yeah, that's it. Thank you.